Assalamu alaikum students. As we have already read the variation of g with height, with depth, and what we found that the value of acceleration due to gravity, the value of acceleration due to gravity decreases with both with height as well as with depth. Now we have to read about the variation of g with the shape of Earth. Actually, the shape of Earth is not fully spherical. It is, you can say, an egg shaped, oval shaped, so that it is having, this is called as the equatorial radius and this is called as the polar radius. The equatorial radius is 21 kilometer. Equatorial radius is greater than radius at the poles, and by a factor of what? 21 kilometer. As wherever that g, the acceleration due to gravity, is equal to gm over r square, where r is the radius. Now acceleration due to gravity at equator will be equal to gm by r equator square. Similarly, we can have g at poles equals to what? G, it's not going to vary. M, the mass of Earth, that's not going to vary. But we are having the r at poles square. Now, as this g is inversely proportional to radius. Now, as already I have placed that r equatorial is greater than rp. Once this is greater, then this will be smaller. Therefore, g equator will be less than g at the poles, which we have to remember. The value of acceleration due to gravity at poles is much greater. Is much greater as compared to value at the poles. So, if we take a body from equator towards the pole, from equator towards the pole, body taken, if a body is taken from equator to pole, its weight will increase. Definitely its weight will increase. Why it will increase? Because as the g gets increased, g at poles is greater as compared to g at equator. So with the shape, we will say the value of g is increasing as the body moves from equator towards the pole. So the weight will also increase as the body moves from equator to pole. But if the body moves from pole to equator, its weight goes on decreasing. Is it okay? Now we can have another topic there, that is the gravitational field. Gravitational field. What do you mean by gravitational field? As you have read in your 10th class electric field, magnetic field, as you say, the electric field is the space or region around a charge. Similarly, you are having the gravitational field, it is the space around a body within which it is gravitational force of attraction is experienced by other bodies. So simply, if you are taking this as a body, there's a body here, and if its gravitational field is up to this very point, so here, here, this is the space, this is the region around this very body of mass m, up to which its force of attraction is felt by other bodies. There's one other term that's called as gravitational field intensity. Now here, if we have to see the gravitational field intensity, now this is the gravitational field of this very mass m. Now if the body is kept here or here or here, so if we are having a unit mass, if these are 10 kgs, then if we'll take the 1 kg, the force experienced by unit mass placed at this very point, that will be the gravitational field intensity here. So simply, if mass m is going to experience, if we are having a mass m and that's going to experience a force F, then how much will be the unit mass experience? The unit mass will experience a force of what? F over m, and that is called as the gravitational field intensity. Gravitational field intensity. So if I will take this very point, this as this forms a sphere around this very body, the gravitational field at all these very points will be same, but the gravitational field intensity here and here and here and here and here, and it will be totally different, because it is the force experienced by a body of unit mass when placed in the gravitational field of some body. This is the body of mass m, it is having gravitational field up to this very limit. Here will be a gravitational field, here is gravitational field, but how much will be the force experienced by unit mass when placed here? That is called as the gravitational field intensity. If we know that the gravitational force between two bodies of masses, if we are having a mass m here, mass m here, then they will be having a force F equals to what? G m m over r square, if they are separated by distance r. Now we know F over m, F over m, that is how much? G m over r square. But this gm over r square, that is the g, so F over m equals to what? That is the g. R equals to what? E. This is a vector, this is a vector, and this is also a vector, and its unit will be same as that of the g, that will be Newton per kg. So gravitational field intensity at a point gives us how much force experienced by unit mass when placed at that very point. This is all for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.